Okay, so good day to our grade 8 Agri Science High School students. We are on our 10th lesson. Okay, so let's try to solve this problem. The sides of an isosceles triangle are 5p plus 20, p plus 196, and 3p plus 76. If p is a positive integer, what is the greatest possible perimeter of the triangle? So how do we find or how do we solve for the perimeter of a triangle? So p is equal to the sum of the three sides, a plus b plus c, given that we have here our triangle sides a, b, and c. Okay, so since we know that these are the side measurements of our triangle, so let's try to add all of them. So the perimeter is equal to 5p plus 20. So that would be our first side measurement. Then we will have p plus 196, and then 3p plus 76. Let's try to add all of them. So 5p plus 20 plus p plus 196 plus 3p plus 76. So that should give us the perimeter, that is capital P. So 5p plus 1p plus 3p, so that should give us 9p. And then 20, you can use our calculator. 20 plus 196 plus 76, so that should give us around 292. So therefore, the total perimeter of our figure is 292. Okay, so how do you find the maximum perimeter that we can create for this figure given these side measurements? Okay, so we know for triangles to become triangles, they need to have two side measurements. The two smaller side measurements, the sum of those two smaller side measurements should be greater than the biggest side measurement that we have. So that is what we commonly know in the triangle inequality theorem as the main theorem for triangles. In order to consider in order for triangles to exist. Okay, so the sum of their two smaller sides should be greater than the biggest side in the triangle. Okay, so stating that would be a plus b should be greater than c. Now in this problem, we don't know which is the biggest among the three sides. Okay, so what we're going to do is we're going to try to find all three possible values for p using linear equations. So for this one, since this is our side A, since this is our side A, this our side B, and this our side C, we can equate these three variables that we have. So A is equal to B is equal to C, and A is equal to C. For A is equal to B, we have our first equation. So that's 5p plus 20 is equal to p plus 196. Solving for p, we have 5p minus p is equal to 196 minus 20. So that's 4p is equal to 176. And 196 minus 20 is 176. And what's 176 divided by 4? So therefore, p is equal to 44 for our first case. For our second case, we can say that b is equal to c. They could be isosceles triangles for all we know. So we can write here p plus 196 is equal to 3p plus 76. We can say that 3p minus p is equal to 196 minus 76. 196 minus 76 is equal to 120. And that's equal to 3p. If we divide both sides by 3 for this problem, so therefore 120 divided by 3, so that's equal to 40. For our second case, the value of p is equal to 40. So let's try for our third case, number 3. For our third case, we have a is equal to c. So that's 5p plus 20 is equal to 3p plus 76. We can say that 5p minus 3p is equal to 76 minus 20 for this case. So therefore, we can say that 5p minus 3p, so that's equal to 2p. And 76 minus 20, so that's equal to 56. And if we have to divide both sides by 2, so 56 divided by 2, so that should give us p is equal to 28. Okay, so that's our third set of sides. Okay, so those are all of our sides. If they are isosceles triangles. So that's 5p plus 20 is equal to p plus 196. After equating them, we do get those values, right? And then for the second one, we have 196 minus 76 is equal to 3p minus p. Oh, wait. This should be 2p. I'm sorry. Okay, wait. So this should be 2p. This should be 2, just to double check. And this should be 2. And this should be 2. Because 3p minus p is 2p. So this should give us 120 is equal to 2p. And if we divide both sides by 2, so therefore for the second value, p is equal to 60. Okay, so from the three values we have for the first one, p is equal to 44. For the second one, p is equal to 60. And for the third one, p is equal to 28. Which is the largest, or which is the biggest value? It has to be the second one. Okay, and for this triangle, we can say that since the perimeter of the triangle is equal to 9p plus 272, we can substitute the value of our small p here, the biggest one, which is 60. So that's 9 times 60 plus 292. Okay, plus 292. So therefore the perimeter, the biggest perimeter that we will have would be 9 times 60. So that's 540 plus 292. And 540 plus 292, so that should give us 832 units. So therefore the largest or the maximum perimeter that this triangle could have would be 832 units. So that would be letter B for this problem. And that's how we solve this problem.